Hello, everybody, and welcome to the next session. I'd like to welcome our next presenter. Dr. Dragana Popovic Renella is the COO of SENIS AG in Switzerland. Before co-founding SENIS, she worked at ETH Zurich, Centron, and Credit Suisse. Dragana is a Swiss member of the Technical Committee of the International Measurement Confederation. Welcome, Dragana.
Thank you for this introduction. Hello, everybody, and welcome to my presentation, Fast Magnetic Angle Sensor for High-End Robot Control Applications. I am Dragana, and the co-authors of this presentation are Dr. Thomas Kaltenbacher of SENIS Switzerland and our colleague, Mr. Lennart Nachtigall of the Robotics Systems Lab at ETH Zurich. Our company, SENIS, provides smart sensors and instruments for magnetic field and electric current measurements, for test and measurement, automotive, robotics, and other industrial applications. We provide analog and digital magnetometers, for example, such as the world's most precise 3D Tesla meter with the smallest 3-axis Hall probe. SENIS is the only provider in the world of integrated 3-axis Hall probes that has an accredited calibration lab. We also provide precise 3-axis magnetic field mappers, smart sensors, including 3D Hall sensors, magnetic angle sensors, and any axis current sensors and current transducers. Today, I will present the SENIS FAMAS sensor that is an accurate and fast magnetic angle sensor which has already won an innovation award. The sensor performs with an outstanding robustness. It has an excellent stability and high resolution, even at very fast rotational speed, which is unique in the market. The sensor is perfectly suitable for motor control in a wide range of high-tech applications, for example, robot control. And today in this presentation, I will talk about FAMAS used in robot control applications. This slide shows pictures of robots developed at the Robotics Systems Lab at ETH Zurich. The name of this robot is ANYmal. ANYmal is a quadrupedal robot designed for autonomous operation in challenging environments. The system is driven by precisely torque controllable actuators. The robots have incorporated lots of sensors and cameras, and thanks to that, they can autonomously plan their navigation paths. One application of these robots is industrial inspection of oil and gas sites. The SENIS magnetic field angle sensor FAMAS has been applied in this robot application for precisely measure angle for very high resolution and accurate position control of fast controllable actuators. And I cite Mr. Lennart Nachtigall, the robotic systems engineer at ETH Zurich. The requirements for use in the motor drive robot applications include, among others, a high angle resolution, fast response, an affordable price, and small size. And the combination of all these requirements could not be satisfied with previously applied magnet-based absolute encoders. Further requirements for use in the remote applications is the stray field immunity and robustness. A robust solution in the sense of allowing small deviations in the fastening of the magnet and the sensor. That in turn allows the use of lower cost structural parts, but robust also in the sense of stability, accuracy, and calibration. And again, I cite Lennart. What is cool about FAMAS is the easy to use from the electronic and programming point of view. This slide shows a test application of the FAMAS sensor connected to the motor controller. It is similar to the final integration into the robot. Here is shown the FAMAS sensor soldered to a PCB and then connected to the motor controller. The engineer holds a small magnet which is diametrically magnetized. For this test application, they simply read out of FAMAS the absolute angle of the rotating magnet, and they map the output signal into the LED ring. So by rotating the magnet by 360 degrees, the LEDs turn on one after the other. So you may imagine this from this picture. The robotic systems engineer who applies the FAMAS sensor in the robot says, what is particularly impressive is that even though I have the sensor hanging freely and the magnet in my hand, I got pretty good readings. I think the strength of FAMAS is definitely its robustness. In other words, the sensor system allows small deviations in the fastening. This test application is similar to the final integration into the robot. So in the final integration, the FAMAS is used in the knee of a robot leg, and it is then connected to the motor with a plug connection. Now, on these few slides, we got an impression on FAMAS used in robot application, and we have heard the customer's feedback, which is the most important reference for a new sensor. But FAMAS has received also other acknowledgements. For example, FAMAS is the winner of the prestigious European ANYmal Award 2020. FAMAS has also received the Seal of Excellence from the European Commission because FAMAS is an accurate and fast and robust magnetic angle sensor, which is based on two innovations protected by patents. Why did we develop FAMAS? Because originally we got a customer request for fast and precise measurements of magnetic angles. On the market, available whole magnetic angle sensors lack of performance and reliability for some applications. For example, there is restricted magnetic field range, low accuracy or low speed, slow response time, the sensors are noisy. There is insufficient functionality. The sensors need additional AD converter or additional angle calculation. And this is not only costly, but also time consuming. The sensor needs more time to react. It is slower. Various FAMAS is fast and precise. In our FAMAS sensor, we apply an innovative algorithm that naturally measures the angle direction of the rotating magnet without any AD converters or angle calculations. This innovative mechanism is a so-called servo system-like control loop, which I will explain later in this presentation. Just briefly, the regulation system is designed in a way that the sensitivity vector of the sensor always follows the direction of the magnetic field to be measured. That's why it is called servo system-like. This mechanism makes the measurement inherently fast. The exact angle is given at any time and with a latency of less than 1 microsecond. Latency means the delay of change of the sensor input until it is visible at the sensor's output. And this with an angle resolution of better than 0.09 degrees. FAMAS is accurate and fast and robust, and these performances are required for high-end robot applications, for example, as shown in these quadrupedal ANYmal robots that are driven by precisely torque controllable actuators. The combination of high angle resolution, fast response, and robustness could not be satisfied with available whole magnetic angle sensors. And that's why the new FAMAS found its application in high-end robotics. And now let me explain on the next few slides how FAMAS can achieve these better performances. This slide shows a block diagram of our patented method of magnetic angle retrieval in FAMAS. The mechanism is a so-called servo system-like control loop. Let me briefly recall you what a servo is. A servo uses error sensing feedback to correct the action of a mechanism. And this is exactly what we do in our sensor system. We correct the position of the sensitivity vector S of the sensor to be always orthogonal to the magnetic field B. And that's how we can achieve extremely fast measurements compared to other magnetic angle sensors on the market. The other sensors on the market have to always search the magnetic field vector in the entire circle of 360 degrees before giving the angle, and that makes them slower. In our system here, we use two vertical Hall sensors. The sum of their sensitivity directions gives us the sensitivity vector S of FAMAS. The direction of S can be adjusted by the biasing currents of the two Hall sensors. The two Hall sensors are kind of an error sensor that measure the difference between the actual measured value of FAMAS and the magnetic field direction of the dipole magnet. With this error information, the system adjusts the biasing currents of the Hall sensor in order to make the error even smaller, ideally zero. And this goes through an up-down counter, a lookup table, and a digital to analog converter where the analog biasing currents are generated. The result at the output of FAMAS is a digital signal. Our servo system-like control loop allows very fast detection of the angle of a rotating magnetic field vector in the sensor chip plane. And this with a resolution of better than 0.1 degrees in less than 1 microsecond. FAMAS rotational speed is 400,000 rounds per minute. This slide shows the two Hall elements enlarged here. We apply two vertical Hall elements in our system. I mentioned that FAMAS is based on two innovations. One patented innovation is this servo loop method of fast measuring magnetic angles, and the other patented innovation are the high fidelity vertical Hall elements. The novel vertical Hall devices shown here and applied in FAMAS feature at least 3 times better signal to noise ratio than any other vertical Hall devices available on the market. FAMAS IC incorporates two such vertical Hall elements with mutually perpendicular sensitivity directions. The unique high magnetic resolution of the vertical Hall elements allow the high angle resolution of the FAMAS sensor. And because of their very small size, they also allow a very compact magnetic field sensitive volume of FAMAS, so that even small magnets can be applied in your measurement system. And because we use pure silicon CMOS technology and no post processes, even high fields cannot damage FAMAS functionality. This slide shows FAMAS value proposition. The FAMAS is accurate. It has the highest rotational speed, the highest angle resolution, and the fastest response. The largest magnetic field ranges from 20 millitesla to 400 millitesla and higher. Small angle sensing volume of 100 times 100 micrometer square, which reduces the error contribution from magnetic field non-uniformity. The sensor has stray field immunity and on-chip correction of sensitivity, offset, noise, and temperature drift correction. The sensor is affordable because you don't need any AD converter, no additional angle calculation. There are no additional post processes. The sensor is feature rich. New patented angle sensor concept. The sensor gives practically instantaneous angle information. There is on-chip parameterization. For example, you can set the zero angle position, and there are various interfaces. Sensors and evaluation kits are available. We provide the packaged sensors, and we also provide the evaluation kits. In the evaluation kit, the sensor is mounted on a PCB and then connected to the controller, a Raspberry Pi, and you may connect this controller to your screen, on which you will see the graphic user interface. And then you can start playing with the kit. You can immediately measure your angles. And so you may set the magnetic field range, the zero angle position, and so on. And then you see the angle and speed measurement. Let me quickly recall this slide where we talked about the magnet and its position. The FAMAS sensor is robust and it allows small deviation in the positioning of the magnet and the sensor. And this is a very nice feature. However, in order to optimize the functionality of your magnet sensor system, you should know well the magnet that you are using. You should know how it is magnetized. In the ideal case, the magnetic field lines would look parallel like this, but in reality, you will always have some magnetization error, some intrinsic angle errors of the magnet. And in order to optimize your system, you should know well what these errors are. And you can know it only if you measure your magnet. And how is this magnet measured? Usually, the magnets are tested and measured with the SENIS magnetic field mappers. The mapper incorporates a 3-axis Hall probe that maps the magnet, and it gives you 3D graphs of the magnetization. And it shows the intrinsic angle errors of the magnet and so on. So several companies worldwide apply the SENIS magnetic field mapper for the tests of their magnets and motors. For example, Maxon Motor in Switzerland or Bomatec and many others. Well, once you know your magnet well, then you can optimize the parameters in FAMAS. And so you can optimize your motors for a smooth motion. Now let me go back to FAMAS and summarize. FAMAS is accurate, fast, robust, and it has been awarded. FAMAS has received excellent customer feedback from high-end robotics application, and a big thank you to the Robotics Systems Lab in Zurich for that. On our website, senis.swiss/sensors, you will find data sheets and application notes of FAMAS, and also other sensors like, for example, the 3D Hall sensor and the any-axis current sensor. But now I would like to briefly show you a video on FAMAS. So I would like to thank you for your attention. And now let me see if there are some questions. Yes, I got a lot of questions. So, and my colleague Thomas already started, I think, answering some of the questions. So, where can I get the sensor kits? So if you are located in Europe, so you may contact us directly, SENIS Switzerland. If you are located in the USA, you may contact GMW Associates in California. By the way, GMW also have a stand at a virtual stand at this conference, so please feel free to visit them. So another questions that we usually get is if you can send your magnets for test to us. Yes, you can. We provided these test services for your magnets where you can characterize the magnet. We can map them on our system and you get a report. Good, no further questions, or I don't, they were already answered, yes. Good. Okay, thank you very much. Bye-bye, see you.